Thank you, Ken. I would like to thank all the organizers for inviting us to speak here today, and I would like to thank you all, ladies and gentlemen, for coming here to listen to us today. Can everybody hear me well? Okay. So I will do most part of the speaking. Dr. Guzman is right here. If you have any questions, please feel free to ask us at any moment. So just a short introduction of EdLoc. We have been around for about a year. We're quite a young company. We're based in Calgary. We're an applied scientific research company. We're specialized in earth sciences, and we are a service and product provider. Our primary market is Alberta, but we are looking into working in North America and eventually globally. So Alberta being our primary market, we're here today in the capital of Alberta talking to you. We are looking for partners in the projects that we are working on, and I will talk about this a bit later. I think I'll go on to the next slide. So this is the description of what we do as a company. So you see there are three major blocks of the services that we are offering. We offer turnkey solutions to a number of different industries. These include agriculture, green energy, petroleum industry, pipeline industry. We do provide services for field workers in Alberta, North America, and eventually around the globe. The three major groups of services two major groups of services and the products that we provide. First of all, this is numerical modeling, and this includes all kinds of scenario analysis for any kind of natural or man-made occurrences, such as you can see here, oil spills, air pollution, blizzards, droughts, landslides, mudslides, impacts on ecosystems by any kind of natural resources development, avalanches, and climate change scenarios. From a forecasting point of view, we provide forecasts for more than 40 variables, atmospheric, ocean, and land surface variables. So you can see examples of some of the variables that we do forecasts for, and this is not at all a complete list. Instrumentation-wise, right now we're in the design stage for an agricultural weather station. We are offering a number of different weather stations for different applications in maritime industry. As I mentioned, the agriculture right now is the focus. There are alpine weather stations and a miniaturized weather station that's good for any kind of application, both for individual and for industrial application. These are some of the examples of how our services are being used in different industries. For example, if we're talking about, that's right, if we're talking about field work, then we provide year-round support for people working in the field. These are forecasts. It can be numerical modeling as well. In terms of forecasts, geometrics interface makes it easier for every forecast to be understood, and this interface represents the region for which the forecast is being done. So it represents the topography and the physical geography. The weather forecasts can be done in a simple form, like you can see here, or as complicated form as necessary. So it really depends on who is looking for these forecasts. Then each forecast comes with the graphs and meteograms, like you see here. These are applicable, as you can see here, for agriculture, for example, for all kinds of transportation, water transportation, all kinds of helicopters and aircrafts, rail, trucks. We do also statistical data treatment, and here water management, which can also be applied for irrigation management in terms of agriculture. Now coming to the actual point of this whole presentation. We are, as I mentioned before, we're in the design stage of the agricultural weather station. This is a new project, and we consider it quite an innovative project, since this weather station, you can see, this is, of course, a representation of what the weather station would stand for. So the idea of the weather station is to be applied for plants that grow underground. So we can see in this case we have an example of potatoes and carrots. It can be used for any kind of plant that has the underground part of it, which is very important. So the difference between a conventional weather station and what we are designing right now is that with our weather station you can monitor your plant above the ground and below the ground at every 5 or 10 centimeters or every centimeter that's required. And then all those sensors represented here, for example, every sensor stands for a different thing. For example, relative humidity, water saturation, it can be temperature. On top you can get the, for example, sensors for the wind speed, for the temperature. So pretty much everything that a plant may need to be monitored, you will get in this weather station. So the result, you will have those very nice, beautiful potatoes, those wonderful French fries and crispy chips, and this very nice crispy carrots, and this very good juice, the carrot juice. So as we see the agricultural industry as such, and it's not only talking about the carrots and potatoes and maybe beets, but in general, we see there is even, we live in the 21st century when we're so much technologically advanced, even though still the crops are so much vulnerable to all those natural occurrences like floods and droughts and storms and freezing, all those sudden temperature changes. So we see this as a problem, and we believe we have a solution, actually a three-part solution, as you can see here. The solution consists of looking into historical data, looking into what's going on right now, and trying to predict what's going to happen in the future. So with monitoring, we are looking into what's going on right now. So using this customized weather station, you will have a perfect idea of what's going on with the plant at this moment, at any point of its development, at any height, below the ground, above the ground, on the surface. Then this data and information that you will be getting from the weather station is complemented by modeling, which takes into account historical data and current data, and that produces the forecasted data. And this gives you all kinds of scenario analysis of what can happen, what happened before, what can happen next to the plant that's developing, that's growing. And finally, the forecasting stage is very important to know what's going to happen in the coming, let's say, 7 days, which is enough time to make, to do the decision making regarding pretty much everything from fertilizing to harvesting. So pretty much every important decision that has to be made regarding the plant that's being grown. So which leads us to the next part of the solution. Once you have the basic solution, which is prevention, you try to protect your crops from any nasty thing that can happen. But this is just the beginning of the solution. Now, if you want to get more out of it, not just protect it, but get the most out of it, then you would go for optimization. And using the very same tools that we are talking about here, we'll look into optimization of every process that is being done for the plant. from the moment it's being planted to the moment the crops are being harvested. So it's planting and irrigation and fertilizing and dispersing, crop protection, and finally harvesting. I'm sorry. There are some more details on what the solution is all about. So as I mentioned before, we're starting with the monitoring, this part. So the monitoring is being provided by this customized weather station. These are just some examples of how the information can look like that you would be getting from the weather station. This is a simplified version. This is, well, this is a forecast version, but this is how it can also look like if we are talking about a large number of variables. Here, for example, you're getting something like 10 variables. You can get up to 40 variables, so it will be a more complicated data set. And then the same information can be represented in the form of graphs and charts. Then if we're talking about forecasting, forecasting is done 24/7 by 365, and forecasts are provided 4 times a day. So 4 times a day you would be getting an updated forecast for the coming 7 days or 168 hours of what's going to happen to your plant, and that's 40 plus variables. Okay. These are some of the examples of the meteograms that you would be getting with every forecast. And finally, modeling. This is our proprietary numerical modeling system represented here. This will be giving you the idea of what's going to happen with the crops given any kind of conditions, given whatever decision you're going to make regarding your crops and your plants. We have quite a large number of collaborators that we're working with. Right now, all of them are academics, so we can see a number of Canadian universities here, 2 US universities, and 2 universities in Mexico and 1 in Argentina. So we have collaborators all over North America and in South America as well. This is our website if you want to get more information about us. We have some leaflets that you can grab a copy and have all the information there. And finally, what we are looking for, we have designed the weather station. So we're looking to partner with a company, with an institution who would be willing to test the prototype with us. We are looking to do a pilot project with an interested company, farm, who would be willing to try out our weather forecasts. And we can do a sample forecast for you completely for free if you're willing to try it out before considering this. We offer statistical data treatment, so if somebody is willing to do a pilot project on this, this is also possible. We are looking to do coupling of our in proprietary model with the Alberta irrigation management model, and we have an atlas of surface variables, so it's temperature, it's wind, it's all historical data. We are looking to do a pilot project involving this kind of data and see how it works out for the farmers. And this is it.
Any questions? Right here.
Thanks for your talk. I just have 2 small questions. First question, this is a real-time process, so what's your radius range that these weather stations are measuring?
Oh, that's for Dr. Guzman.
Yes. Well, the wireless station right now with the technology and not the typical should be 100 meters, but it can. There are also some emitters that can be half kilometers, or the other solution there can be repeaters, just like the cell phone, and you put a tower, another tower, so you get information as far as you need. So if you have in your truck the station, you can get all the information because, well, the idea is that in solid state you can keep the record of all the variables, all the values. So you just need to pass by and get all the information you need. So that's the idea.
And one other quick question. So you have 40 variables that you're measuring. What would you say is your most difficult variable to measure, or your most unique variable?
Well, always the most difficult variables are the derivative variables that you actually need. You have like the primary variables and then the secondary or third variables. So if you cannot control the primary variables like atmospheric pressure, temperature, either on the soil, and precipitation, or amount of snow, kind of ice, solar radiation. If you cannot control those variables, then the next cannot be controlled. For example, vorticity. Vorticity is one of the most important variables in atmosphere because those give you the idea of how all the turbulence will happen. But how can you control the turbulence if you cannot control properly the temperature to see the thermals or all these phenomena?